Good morning. In today's session, we will learn about the input-output pins, ports, and circuits of the 8051 microcontroller. Now, this is probably asked as an essay question. So, we will start. Now, regarding 8051 microcontroller, one of the most important feature of this microcontroller is the versatility built up into the input-output circuits. Okay, that connect the 8051 to the outside world. That is, it is highly versatile in the sense that this 8051 microcontroller can be connected or it can be interfaced to the outside world using various input output circuits. Okay, now the microprocessor designs must add additional chips in order to interface it with an external circuitry. That is, in order to connect the microprocessor to the outside world, some additional chips or some additional interfacing circuits becomes necessary. So that is why we say that it is the design of 8051 is highly versatile or flexible. Now 8051 incorporates many functions and its design is highly feasible, but one of the most important condition that limits 40 pins. And so regarding the in the sense of pin number, there is a slight drawback, that is the success of the design in the marketplace is mainly determined by the flexibility uh, of the pins. Okay, so for this reason 24 of the pins is used for one of the two different functions, thereby giving a total pin configuration of 64. Now the function of a pin mainly depends mainly depends on two factors. One is to which it is physically connected to, and the other is on what software on what software or based on which software that particular pin is programmed. Okay, now both these factors are completely under the control of the programmer or the person who designs the circuit. Now, but it is a common factor that 8051 possesses pin flexibility. Because of that reason itself, 8051 can be expanded to include additional memory, parallel ports, and serial data communication by using alternate pin assignments. Now, the main factor or the main key to programming an alternate pin function is the port pin circuitry, which we will discuss now. Now, there are four ports. One is port 0, port 1, port 2, and port 3. Each port has a D-type output latch for each pin. The special function register, that is SFR, for each port is made up of 8 latches, and each of these latches can be addressed using the port latches and port pins. Both of them are not the same. Okay, that is, the data on the latches does not have to be the same as the data on the pins. Okay, that is the pin data, that is the data on the pin, or the latch data, that is data on the latch, is read using two separate buffers, that is using a top buffer and a lower buffer. Now top buffer is enabled when latch data is read and lower buffer is read when pin state is read. Okay, now the status of each latch can be read from a latch buffer, whereas the input buffer can be connected directly to each pin. So we can say that the status of each pin, that is the condition of each pin, can be read independently of the latch state. That is, the condition of the pin does not depend upon the state of the latch, or status of pin or the state of the pin does not depend upon the state of the latch. Both of them are different. Now different operational codes or op codes will access the pin state or the latch state as appropriate. Now, port operations are determined by the manner in which 8051 is connected to external circuit. So, depending upon how 8051 is connected to external circuit, we can determine the port operations. Now, only port 1 cannot have alternate functions, whereas port 0, port 2 and port 3 can be programmed according to our needs. So, first is port 0. Port 0 pins is mainly used as input output, or when used together they are used as bidirectional lower order address and data bus for external memory. For example, uh, when a pin is to be used as an input, then transistors which is shown in the circuit, both this transistor will be switched off, and this will cause the pin to enter into the float state, that is high impedance state. Okay, so this is the port 0 pin configuration, the circuit diagram for port 0. When it is used as an output, that is when port 0 is used as an output, what happens? Just the reverse. The pin latches will be programmed to a 0, that is a 0 will be written, or that will turn the lower FET. That will turn on the lower FET. That is, here you can see an FET, this one, and this is the FET, and all the latches that are programmed to 1 will continue to be float. Here we say that some of the latches are programmed to 1, and those latches will continue to be in their float state. This will pull up the transistors, so that a logic high will be produced when port 0 is used as the output. So, when port 0 is used as output, a logic high will be produced. Now, what happens when port 0 is used as an address bus? These are the various uses. They are predicting it one by one. What happens when 1 is written? What happens when 0 is written? And now what happens when it is used as an address bus to external memory? In such cases, the internal control signals will switch the address lines to the gates of the FET. A logic 1 will turn the upper FET on and the lower FET will be off. And this will provide a FET will be on and the upper FET will be off, and this will produce a logic low at the pin. That is, now the pin which was at logic high is now become logic low. Now, once the address is formed and latched into external circuit, then there will be a pulse, address latch enabled pulse will be initiated, and the bus will now turn around to become a data bus, that is address bus becomes data bus. Now, when it becomes data bus, port 0 will now read the data from external memory and will be configured as an input. So, a logic 1 will be written in the port 0 latch. Now, port 1, it have no dual function, so the output latch is connected directly to the gate of lower FET, which has an FET circuit label, that is internal FET pull up. That lower FET is named as internal FET pull up in the case of port 1, and the circuit or the pin configuration for port 1 is shown here. When this port 1 is used as an input, as I said earlier, a 1 will be written to the latch. This will turn the lower FET off, and the pin and the input to the pin buffer will be at logic high. Then an external circuit can overcome the high impedance pull up, and it can drive the pin to low, or it can leave the input high. So that is not needed. You can write this one, that is when port 1 is used as an input, a 1 will be written to the latch. This will turn the lower FET off, whereas the pin and the input to the pin buffer will be pulled to a logic high by the FET. That is enough. Now, what happens when it is used as an output? When it is used as an output, is written to the latch, lower FET will be turning on, and the pull up will be off and the pin will drive the input of the external circuit low. So the first paragraph is about the function of port 1. Then the next paragraph tells us about what happens when port 1 is used as input. Then this paragraph deals with what happens when port 1 is used as output. Okay, now to help in speeding up switching times when the pin is used as an output, the internal FET pull up will use another FET which is connected in parallel with it, and that FET, that is called the second FET, it will be turned on for 2 oscillator time periods during a low to high transition on the pin. So this arrangement, that is the connecting the internal FET pull up with an FET parallel to it, that is that arrangement called, it will provide a low impedance path to the voltage supply, and this will reduce the rise time in charging the capacitor in the external circuit. Next is port 2. It can be used as an input output port similar to port 1. Another use, the alternate use of port 2 is to supply, that is it supply a higher, its function is to supply a higher order address byte in conjunction with port 0 lower order byte to address external memory. That is, it uses a higher order address byte in connection with port 0 lower order address byte. For what? Just to address the external memory. Now, port 2 pins are momentarily changed by the address control signals when supplying high byte of a 16-bit address. They remain stable when external memory used as an input output port similar to port 1, and port 3 has got alternate uses. It is tabulated here. P30 means port 3 pin 0. Okay, it is used as RxD, that is serial data input. The other one is port 3 pin 1 is TXD, that is serial data output. Now port 3 pin 2 is INTO bar, that is external interrupt 0. The other one external interrupt 1. Then P34 external timer 0 input. P35 external timer 1 input. WR bar is external memory write pulse. RD bar is external memory read pulse. So unlike port 0 and 2, which can have external addressing function, that is port 0 and 2 can have external addressing function, and it can change all 8 port bits when in alternate use, whereas each pin of port 3 can be individually programmed. That is the main highlight, that is each pin of port 3 can be programmed individually either as input output or as one of the alternate functions tabulated here. This is a pin configuration of port 3. So when asked as an essay question, you will have to draw all this pin configuration, and you will have to mention a brief paragraph on each of these ports. Okay, when you compare these figures, that means the circuit diagrams, there is a slight similarity, there will be only a light differences. So this is the, if you want you can make it a little bit brief. So when asked as an essay question, you must you have to include all these points. Okay, just write a short paragraph about each of these ports and draw this pin configuration circuit diagram. Okay, thank you.